Okay, this is LT 2.1. Use inductive reasoning to make conjectures and find counterexamples. So you need to find the next item in the pattern. January, March, May should be July. Skips every other month. Find the next item in the pattern. 7, 14, 21, 28, 35. Multiples of 7. Find the next item in the pattern. It should be pointed that way, because if you look, that's pointed that way, and then to the right. So inductive reasoning is the process of reasoning that a rule or a statement is true because specific cases are true. So this is how we go about our daily lives. We make judgments based on inductive reasoning, based on patterns that we've seen or examples that we have observed. It is basically something that we think to be true based on specific examples. So every day I go to school, and when I get to school, my teacher has a warm-up on the board. Today I get to school, so I can assume that there will be a warm-up on the board. It's more of assumptions based on things that you have experienced. So inductive reasoning is the process of arriving at a conclusion based on a set of observations. In itself, it is not a valid method of proof. Just because a person observes a number of situations in which a pattern exists doesn't mean that the pattern is true for all situations. For example, after seeing many people outside walking their dogs, one may observe that every dog that is a poodle is being walked by an elderly person. The person observing this pattern could inductively reason that poodles are owned exclusively by elderly people, which is not necessarily true, but that is an example of inductive reasoning. Because I see every elderly person walking a poodle, then poodles are only owned by elderly people. This is by no means a method of proof. In fact, in the real world, it is a means by which people and things are stereotyped. This is, however, the most common way people reason throughout their lives and learn about their surroundings. A hypothesis based on inductive reasoning can, however, lead to a more careful study of a situation. By inductive reasoning, in the previous example, a viewer has formed a hypothesis that poodles are owned exclusively by elderly people. So the observer could then conduct a more formal study based on this hypothesis and conclude that the hypothesis was either right, wrong, or only partially wrong. So this is a means of forming a hypothesis. It's not technically a proof. Inductive reasoning is used in geometry in a similar way. For example, Seth observed 4 rectangles, and in all 4 rectangles the diagonals are congruent. Seth concludes that diagonals in a rectangle are always congruent. For example, the diagonals, he means that those 2 diagonals are congruent no matter what size my rectangle is. So now he would use a formal proof, which is something we will get to, called deductive reasoning, in order to prove that. But by inductive reasoning, he was able to observe what he wanted to prove. Although we know this fact to be generally true, Seth hasn't proved it through his limited observations. However, he could prove his hypothesis using other means, which we will learn later, and come out with a theorem, a proven statement. In this case, as in many others, inductive reasoning led to a suspicion, or more specifically, a hypothesis that ended up being true. The power of inductive reasoning, then, doesn't lie in its ability to prove mathematical statements. In fact, inductive reasoning can never be used to provide proofs. Instead, inductive reasoning is valuable because it allows us to form ideas about groups of things in real life. So whether we know it or not, the process of inductive reasoning almost always is the way we form ideas about things. Once those ideas form, we can systematically determine, using formal proofs, whether our initial ideas were right, wrong, or somewhere in between. So can you think of something you believe to be true based on observations you have witnessed? For example, if it is January, then it is cold. True, depending on where you are in the world. If I am late to school, then I will get in trouble. True, unless you're excused. If I don't tie my shoes, then I will trip in the hallway and everyone will laugh at me. So a conjecture is a statement that is believed to be true. For example, a sequence begins with terms 2, 4, 6, 8, 10. A reasonable conjecture is that the next term in the sequence is 12. Conjecture is something you come up with. So if 2 is a number, 1 is a number, then 2 equals 1. Obviously not true, but it's a conjecture. Sherlock Holmes, Silver Blaze. In the short story, The Adventure of Silver Blaze, Sherlock Holmes solves a murder by establishing the premise that dogs bark at strangers. Silver Blaze is a champion racehorse who disappears from the stables at night, the night his trainer is murdered. Holmes has 2 premises. The dogs didn't. Premises are things that actually happened. Facts. The dogs didn't bark the night the murderer broke into the barn where Silver Blaze was stabled, and dogs bark at strangers. These premises led Holmes to the conclusion that dogs knew the murder. His premises turned out to be correct and led to an accurate conclusion. Holmes solves the mystery and the murder. One could also argue Holmes is using inductive reasoning, essentially reasoning by sign, the clue, and perhaps by cause, because dogs bark at strangers, therefore, ... You're at school eating lunch, you ingest some air while eating, which causes you to belch. Afterward, you notice a number of students staring at you with disgust. You burp again, and the looks of distaste greet your natural bodily function. You have similar experiences over the course of the next couple of days. Finally, you conclude that belching in public is socially unacceptable. The process that led you to this conclusion is called inductive reasoning. A scientist takes a piece of salt, turns it over a Bunsen burner, and observes that it burns with a yellow flame. She does this with many other pieces of salt, finding they all burn with a yellow flame. She therefore makes a conjecture: all salt burns with a yellow flame. At this point, then, she would need to actually prove it in different settings, with different temperatures, and so on. So a counterexample is an example that proves that a conjecture or statement is false. Now, to prove something false, you only need one counterexample, and then the entire thing is false. So on her first road trip, little window watcher Wilma observes a number of vehicles. Each one she observes has 4 wheels. She conjectures all vehicles have 4 wheels. What is wrong with her conjecture? What counterexample will disprove it? Well, a motorcycle. Oops. CYCLE. A motorcycle would be a counterexample, because a motorcycle is a vehicle and it only has 2 wheels. Kenny makes the following conjecture about the sum of 2 numbers. Find a counterexample to disprove Kenny's conjecture. So the sum of 2 numbers is always greater than the larger number. So here's a couple ways to do this. Always test a couple of positive numbers. So 3 plus 4 is 7. The sum is always greater than the larger number, which is true. 7 is greater than 4. So then test negative numbers. -3 plus a -4 is a -7. The sum of 2 numbers is always greater than the larger number. Here's the sum. The larger number is this one. This would be a counterexample. Because it proved it to be false. Show that the conjecture is false by finding a counterexample. For any real number x, x squared is always greater than or equal to x. Well, once again, Try positives. 2 squared is 4, which is greater than or equal to 2, and so on. And that is always true for positive numbers. What about for negative numbers? Well, same thing, because whenever I square a negative number, it's always positive. So then I have to think about fractions and decimals. And if I test 1/2, is that greater than or equal to 1/2? So that's 1/4 is not greater than or equal to 1/2. So my counterexample would be x equals 1/2. And there's many counterexamples. You only need one. So how do you know which numbers to test? Try positives, and then try a few negatives. Try fractions, and if all else fails, try 0. Or you can try 0 first and see if that works. Joe has a friend who just happens to be a Native American named Victor. One day Victor gave Joe a CD. The next day Victor decided that he wanted the CD back, and so he confronted Joe. After reluctantly giving the CD back to his friends, Joe made the conjecture, Victor, like all Native Americans, is an Indian giver. What is wrong with this conjecture? What does this example illustrate? Well, what's wrong with it? He used inductive reasoning, but he only had one example. Inductive reasoning, you need multiple examples to come up with a hypothesis. And it illustrates stereotyping. So find a counterexample for the following. For every integer n squared plus 1 is prime. Well, counterexample could be 3, because 3 squared plus 1 equals 10, and 10 is not prime.